I'll put this up. Okay, so here we go. We're going to cover AC factoring. AC factoring takes place in situations where you're dealing with a quadratic equation with the number in front of your x squared being greater than 1. For example, if we had the equation, now I've got to put one out of my head here. Let's go with 3x minus, sorry, 3x squared minus 13x plus 12 equals 0. There we go. Okay, and I will jump over to question 8 specifically, but I'm going to start off with this one because now that I've set this up and I know what I want to do with it. So here we go. 3x squared minus 13x plus 12 equals 0. With AC factoring, we want to remember that this really is about the form ax squared plus bx plus c equals 0. So that the a that we're looking for and the c that we're looking for are there. So that immediately what happens when we have a situation like this is we want to set up a sidebar that tells us that we're looking for 3 times 12, which is equal to 36. So there's my 36 that I'm going to be looking for the factors of. 3 times 12 gets me 36. So then I'm going to go through and I'm going to decide on all of the possible factors of 36. So what multiplies to make 36? Well, 1 times 36 gets me to 36. 2 times 18 gets me to 36. 3 times 12 gets me to 36. 4 times 9 gets me to 36. And 6 times 6 gets me to 36. Great. Then I stop and I say, okay, I'm now trying to find which of these pairs of numbers is going to add to negative 13. Because this is a negative and my 36 is a positive, it lets me know that ultimately both my terms are going to need to be negative. So another way to look at it is, if I add them up, what gets me to 13? Well, 1 and 36 get me to either 35 or 37, so that's no good. 2 and 18 gets me to either, I'm sorry, I'm going to do this, I do this in my head, but not everybody can necessarily see this in their head. So I'm going to do this in some different colors here. 1 and 36, I can either get to 37 or I can get to 35. And I don't want either of those numbers. Before I scratch things out, though, I'm going to let you see this whole pattern. 2 and 18, I either get to 20 or I get to 16. 3 and 12, I can get to 15 or I can get to 9. 4 and 9, I can get to 13 or I can get to 5. 6 and 6, I can get to 12 or I can get to 0. I'm trying to find the pair that gets me to 13. It's not there, it's not there, it's not there. There it is, right there. So negative 4, negative 9 are going to get me to 13. Then I go ahead and I'm going to take my negative 13 and I'm going to break it out into negative 4 and negative 9. It doesn't matter what order this goes in. It still works out the same way. So I'm just tend to take it in the order that I've written it down. 3x squared minus 4x minus 9x plus 12 equals 0. So again, to be clear, this 13 is now those things. And they come from this. Now that I have that, I can do some factoring by grouping. We've done this before, so what can I take out of the first two things? Not much. The only thing that seems to be in common here is an x. So we pull out that x, and then I'm left with 3x minus 4. and I took a look at my next two things. What can I pull out of both of those? Well, really a 3 is the best I can do for 9 and 12. I'm going to pull out a negative 3. What's my indicator that I want to pull out a negative 3? The fact that I have a negative in my first bracket, and I want to end up with a negative in both brackets. So I pull out negative 3. And when I do that, I end up with 3x minus 4, which is what I wanted to. Negative 3 times 3 for negative 9. Negative 3 times negative 4 would get me back to 12. Good. Now, my 3x minus 4 is my term that I have in common. So it can be factored out. And then my other term is what's left. From here, we can solve each of these for 0. So 3x minus 4 is equal to 0. Or x minus 3 is equal to 0. Let's make sure that's a 3. There we go. Make sure that's a 3. There. Rearranging this tells me that x is equal to 4/3, or x is equal to 3. And those are our solutions. Sorry, did I disappear for most of that? I just noticed that you couldn't hear me. But I will do a couple more from question 8. I'm assuming you can hear me now. I'm hoping you can hear me now. Testing, testing. Can you hear me now? There we go. Is that better? Testing, testing. Can you hear me now?
I appear to have technical difficulties. Okay, good. So I'm back again. Excellent. Okay, moving on to question 8 from the polynomials. Let's start with, because we want to stay with the AC factoring, I'm going to start with question 8C. And I like 8C because there's a couple of things going on here. So this is from the polynomials. Question 8C. Which says 6x squared minus 4x minus 2. And we just want to factor this. We don't even need to solve in the end. We just need to factor this one. So we start off by multiplying our A and our C. Oh, sorry. Even before we do that, that's why I wanted to pick this one. Even before we do that, first thing I notice, all of my numbers here are even. So in fact, if we wanted to, we could factor a 2 out of this and just work with smaller numbers. like that, which makes life a lot easier. So when I do that, well, now we still go back to our AC factoring, but now our A and C are 3 and -1. So all we're really looking to get to is -3. The joy of -3 is there's only two ways that this can go, or one way that this can go rather, and it's 1 times 3. Now I'm trying to get to -2, which tells me that I want a -3 and a +1. So I'm going to go ahead and do that. And then I end up with 3x squared plus 1 minus 3. Sorry, these have x's on them. Plus 1x minus 3x minus 1. What can I pull out of the first two? Nothing. And when you can pull nothing out, really what you can pull out is a 1. So I have a 2, I have a 1 that I've factored out of this, and an x. So let's go with 1x, which leaves me with 3x plus 1. And then out of my second 2, I can pull out a -1. So I do that, and that leaves me with 3x plus 1. Sorry, this is not in brackets. That should just be sitting outside the bracket, like that. And this is all like that, in square brackets. Now we can pull things together. So this 2 still sits out front. 3x plus 1 is my common term. And then x minus 1 is my extra term. It goes like that. And now because this is all just multiplication, we don't need the big square brackets, and I can have 2 times 3x plus 1 times x minus 1. And now it's fully factored. I'm going to do question D next because it's also another AC factoring one. And this one's going to have much bigger numbers. So D says 5a squared plus 33a minus 14. Nothing that we can factor out of everything, so we're going to go ahead and multiply our 5 times -14, which gets us -70. Now we want all of our possibilities for -70, so 1 and 70, of course, 2 and 35, let's see here, 2, 3, 4, 5, and 14, which is what we just did up there, 7, and 10. One of these needs to be positive and one of these needs to be negative because we've ended up with a negative. So, I should have left myself just a little bit more space. Let me just do that again really quickly with just a little more space. 1 and 70, 2 and 35, 5 and 14, 7 and 10. Trying to find our possibilities. Our high is 71. Our low is 69. Our high is 37. Our low is 33. Oh, good. I don't even have to go any further. I just found my number. Those immediately go away. I want 33. So how do I get to 33? Well, it's a positive 35 and a negative 2. So then we break apart our equation. 5a squared minus 2a plus 35a minus 14. Out of the first two terms, I can pull out an a, leaving me with 5a minus 2. Out of the second two terms, I can pull out a 7, leaving me with 5a minus 2. Fantastic. There's my common term. We pull it out. The other two terms go in the other bracket. And we're done. And then finally, let's do question F, just to stay on the pattern. No, I don't think I can quite fit it in. So I'll just leave people a second to finish writing this down. And then we'll do question 8F. Okay. Eight F is asking us to factor 7x squared minus 23x plus 6. Our ACs are 7 and 6, so we're left with 42. Our factors of 42 are 1 and 42, 2 and 21, 6 and 7. We're trying to get to negative 23. Because it's a negative, I know that both terms need to be negative. Regardless, I go through my routine here. I can get to 43 or 41. I can get to 23 or 19. I don't need to get to 19. I need to get to 23 anyway, so I'm good there. How do I get to 23 and have it be negative 23? Negative 23 is negative 2 minus 21. So then, we put this into our equation. 7x squared minus 2x minus 21x plus 6. Out of the first two terms, I can pull out an x, leaving me with 7x minus 2. Out of the second two terms, I can pull out a minus 3, leaving me with 7x minus 2. My brackets are now the same. And our final solution says 7x minus 2 times x minus 3. Okay, any other questions on the AC factoring? Perfect. Okay. This leaves us with only about 5 minutes left of class time, so I'm not going to try and take up anything new at this point. If you have other questions that you're hoping I'll go over, please let me know, and I will take them up on Tuesday. Otherwise, I am just looking to see people who are writing tests on Tuesday. And if you have any other issues between now and then, please be in contact, and we will try and get them resolved. Thank you very much, everybody, and we'll see you hopefully on Tuesday.